Okay, in this video, we're going to look at solving quadratic trigonometric equations. So it's just like solving trig equations we've looked at before, except now there's going to be a quadratic term, meaning there's going to be a squared term somewhere in there. So if you watched the video, the previous video from the other day, uh, you would have seen one where there was multiple trig terms and we had to solve by factoring. It was common factoring in the previous one. In this case, you've got three terms, 2 sine squared theta plus 3 sine theta plus 1 equals 0. So there's two trig terms, sine squared theta and sine theta. You can't add those together because one's squared. They're not like terms, right? One's squared, one's not. And you're not able to solve for, to isolate for just sine because there's two sine terms. So what you have to do is factor this, much like you would a quadratic. So sometimes when people are doing this, I'll suggest making a substitution first. So that substitution would be let x equal sine theta, to just turn this into not a trig equation. So this would become 2, and sine squared theta would be x squared, because theta is x, plus 3x plus 1 equals 0. And then usually people are okay with that. Now we have a quadratic equation. So now should be able to solve a quadratic equation. How do you solve a quadratic equation? Well, if possible, you factor. There's different methods of factoring. Some people use decomposition. Trial and error is another one. So the leading coefficient is 2. So I know I'm going to have 2x times x. The last term is 1, so the last terms are going to be 1 and 1 if it factors. And then it needs to add up to 3 when I multiply here. So 2 times 1 is 2, and 1 times 1 is 1. So 2 plus 1 is 3, so we're good. So those would be the factors. So I get 2x plus 1 times x plus 1. Now what I could do is go back in and make a substitution, like substitute back in for sine. So we have 2x, but it was 2x's sine theta plus 1, and then x plus 1 would be sine theta plus 1 equals 0. So now I have these two brackets multiplied to give me 0. So anytime I have that, I would just set each bracket equal to 0. So 2 sine theta plus 1 equals 0, or sine theta plus 1 equals 0. So if 2 sine theta plus 1 equals 0, that means sine theta equals negative 1/2. And sine is negative in the third and fourth quadrants. The related acute angle for a half would be pi by 6. So the angles would be, in the third quadrant you take pi plus pi by 6, so you get 7 pi by 6. And in the fourth quadrant you would do 2 pi minus pi by 6, so you get 11 pi by 6. And for sine theta plus 1, that would be sine theta equals negative 1. Here, usually what I would do is think about my sine graph. So whereas sine equal to negative 1, that's here, which happens at 3 pi by 2. So theta is equal to 3 pi by 2. So therefore, theta is equal to 7 pi by 6, 11 pi by 6, and 3 pi by 2. You get all three answers. Okay. The trickiest part probably when people first see this is this factoring business. Right here where I made the substitution, you don't need to make that substitution. If you could see this as a quadratic, where the argument is sine theta and go straight to here, that is fine, completely acceptable. And typically after people try a few of these questions, they can do that. But if you like the substitution, that's fine, go ahead and do it. One just tip or thing to keep in mind, when you make a substitution, make sure that this variable and this variable are different. In this case, this was theta, so usually you wouldn't make that theta, but sometimes you'll have sine x, and people will say let x be equal to sine x. That's wrong, because x, you can't use the same variable. X equals sine x is another equation completely, and your equation probably won't satisfy that equation, so there'd be a problem with your solution. So try not to make that mistake.